Now we have to calculate the distance that the delivery van travels during the 1 second reaction time. So remember that during the 1 second reaction time, he's moving at a uniform velocity of 15 meters per second. So for uniform velocity, we can use this triangle. Average velocity is displacement per time. And so we want to know the distance, which is equal to the magnitude of displacement when we have linear motion as we have here. So we get delta x is equal to average velocity times the period of time. So the average velocity, well, there is only one velocity. It's the constant velocity, 15 meters per second, and multiplied by the time duration. The reaction time lasts 1 second long. So we can see our units cancel there. We end up with meters, 15 times 1 meters. So he travels 15 meters during his reaction time. Will the van stop before the pedestrian crossing? Show all calculations. So we've already seen that he travels 15 meters during this reaction time. Then he's decelerating for another 3 seconds before he comes to a stop. So at the end of that decelerating, he is traveling at 0 meters per second. So we don't know whether that is there or after the crossing. If he only reaches 0 meters per second after the crossing, then he will not stop before. Then he stops after the crossing. So we need to find out how far does he travel, delta x, for this period here, and add it to this 15 meters and see whether that answer is more or less than 50 meters. So how do we find delta x for this accelerated motion? Let's do it in 2 different methods. Obviously in the exam you would only use one, but let's see which one you prefer. So we know from the triangle the meaning of velocity. Average velocity is displacement per time. Displacement is equal to average velocity times period of time. But you have to be careful here, because now there isn't only one velocity. The velocity is changing from over here, initial velocity of 15 meters per second, to final velocity, v final, of 0 meters per second. And so we cannot just put one of those in there, because the average is actually halfway between them because of the uniform acceleration. So we have to, in the case of accelerated motion, substitute v initial plus v final divide by 2 into the part of average velocity. So that gives us the average velocity, and then we multiply that by the time duration. So the initial velocity was 15 meters per second, and we add the final velocity 0 meters per second, divide that by 2, that's going to give us the average velocity, and multiply that by the time duration. We're told it lasts 3 seconds. And so that gives us 15 plus 0 divided by 2 is half of 15, 7.5 meters per second. So 7.5 meters per second is the average velocity for this motion. Multiply that by 3 and you get 22.5 meters. During the reaction time, he travels 15 meters. That was our previous answer. And now, from when he's moving at 15 and starts to decelerate, he travels another 22.5 meters. And then he is standing still, 0 meters per second. So what is his total distance, these two added? So this one was just for the acceleration. Now we have the total for the entire motion. So it's the two added, 15 meters plus 22.5 meters, which gives us 37.5 meters. And 37.5 meters is less than 50 meters. And so therefore he stops before the pedestrian crossing. And so he doesn't hit the people. But I'm going to do the calculation another method as well, just so that we see other ways to do it. So again, we need to know this displacement. We do already know it. It is 15 meters. And what we're trying to find out is the displacement until he comes to a stop. Because if we know that, we can add them together and compare it to 50 meters. So for this interval here, we know the initial velocity is equal to 15 meters per second. And we know that the final velocity is equal to 0 meters per second. How do we know that? Because he comes to a stop. And we know that the time duration for that interval is 3 seconds. What we don't know is the displacement. So when you solve these kind of questions, you should write a list of all the information you know. You can write it one under the other, or else inside the picture as I've done here. Then the next thing you need to do is you need to find a relevant equation. What we're missing is delta x. So delta x has got to be in the equation. Otherwise, how are we going to find it out? So we can eliminate this equation from the list, because the problem with this equation is it doesn't have delta x in it, so there's no way we can use it to find delta x. The others do have delta x. This one is very obvious because we do have v initial, we do have v final, and we do have delta t. And so that's why it's obvious that we could use that one. We need to find delta x. But we've already done that. Let's just see the others too. You can see that in both of them there's acceleration, which might make you think we cannot use it. But you do actually have everything needed to calculate A, because A, acceleration is delta V over delta T. V final minus V initial over delta T. And you have V final, you have V initial, and you have delta T. So let's use this equation. First step, we write our equation. Delta X is equal to V initial delta T plus half A delta T squared. Now I'm going to put another line in where I again put the equation, but this time I replace acceleration with the meaning of acceleration, V final minus V initial, over delta T multiplied by delta T squared. Now I can substitute values. V initial is 15 meters per second, but I'm not going to put the units in. Multiplied by delta T is 3 seconds plus half. V final is 0 meters per second minus V initial 15 meters per second. Divide by 3 seconds, multiply by 3, delta T, 3 squared. 3 squared. That's equal to 15 times 3 is 45. Then plus half, 0 minus 15 is minus 15. So that makes everything here negative. So it's actually equal to minus. So half of minus 15 over 3 is half of 5. Minus 15 over 3 is 5. This part is 5. And then we halve that, 2,5, multiplied by 3 squared, which is 9. And that gives us minus 22,5. And the unit altogether is meters. We're working out displacement. So 45 minus 22,5 is 22,5 meters, which is what we found last time as well. So what have we actually found? We found the displacement, or the distance, magnitude of the displacement of linear motion, the distance, for this interval while he was decelerating. It was 22,5 meters. So let's make some space for ourselves over here. And we continue with our calculation. So this was delta x for the accelerated period, or decelerated if you want to say it. Deceleration is a kind of acceleration. Anyway, that's for the deceleration period, but now we want delta x for the total. And that is simply equal to the two displacements, delta x for the constant v plus the delta x for the deceleration. 15 meters plus 22,5 meters, because 15 meters is what he traveled during the constant velocity time, and 22,5 is what he traveled while he was decelerating. So the sum of the two is 37,5 meters. 37,5 meters is less than 50 meters. And so he did stop before the pedestrian crossing. Will the stopping distance of the van increase or decrease when the road is wet and slippery? The stopping distance will increase. He'll need more distance to stop. Why? Because when the road is wet and slippery, there's less friction to help him. Therefore, there will be a lower deceleration. Deceleration is a type of acceleration, so it's perfectly correct to also say a lower acceleration, or more specifically, a lower deceleration. In other words, his velocity will change at a slower rate. Another way of saying that is, it will take longer time, delta t in other words, to decelerate, or accelerate if you like, to a stop, to 0 meters per second, a stop, and it will also take longer distance.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!